All right, well, I'm really thrilled to be here. Very thankful for the opportunity to talk to you guys today. I want to let you know I'm aware that I am what is standing between you and what promises to be a pretty cool party. I can assure you, you'll have plenty of time to get there. Buildertrend is only about 10 minutes from here, so I will give you, you'll have plenty of time, trust me. Before I start, I wanted to also say I really enjoyed Kathleen's keynote this morning. And legacy software is kind of one of these love-hate sort of things. And we work with a lot of students at the University of Nebraska, and they tend to really be enamored by this idea of greenfield development and starting with a clean slate. But honestly, if I had my choice between that, which we've done a bunch of at Don't Panic Labs, or working on migrating a legacy system, I think I'd choose the latter because I think some of the most interesting engineering challenges are in those legacy application migrations. I think that it really stresses your creativity and your critical thinking. So I really appreciated her talk. So let's get started. I don't have to tell most of you, the last 20 years has been an amazing experience in the world of software. The rate of change in development and sophistication of software products and technology is really breathtaking. About 7 years ago, Mark Andreessen, who was the co-founder of Netscape and also is a pretty active venture capital investor, wrote an essay about how software is eating the world. And in there, he talked a lot about how companies that were traditionally not software companies were transforming to becoming software companies, and how software was becoming ubiquitous in our world and touching everything that we interact with on a daily basis. And really, you know, you could read articles like that and kind of be in this industry and think, man, well, are we at a golden age of software development? The opportunities are really amazing for us. And I'd like to believe that, but for the last 25 years, I've been pretty concerned about kind of where we're headed as an industry. And I will tell you some of the reasons that is things I tend to see on the news. So software systems that are impacting our lives because people not being able to get on aircraft, or who can forget this one, the healthcare.gov debacle that happened in 2013, where just was unable to deal with the scale of the people that, you know, surprise, surprise, wanted healthcare coverage. There was actually a review of this system, of that healthcare.gov system, that had happened 6 months prior to that, and they had identified risky aspects of that program. And I wanted to highlight that they identified inadequate planning or deviations from usual IT standards during the process of developing this critically important and massive system. Facebook famously had a mantra about move fast and break things. They were really encouraging their developers to, let's not worry so much about any instability you might be creating in the Facebook platform. It's more important to get that feature out. In 2014, Mark Zuckerberg stood in front of the developer conference and says, you know what? We had to rethink that thing. Because guess what? All that instability we were creating in our platform, we're spending all of our time fixing bugs and not adding features. And so the new mantra was move fast and maintain a stable infrastructure. Our last election cycle, a lot of evidence that a lot of our election systems had been compromised by people trying to influence our election. These are systems that I would have thought security and integrity would have been a paramount design criteria for these systems. And even less than a month ago, we find out that a software glitch in Wells Fargo system caused the inappropriate or inaccurate foreclosure of people's homes. So people's lives were dramatically impacted. Last summer, there was an article in The Atlantic that had a pretty ominous title to it, the coming software apocalypse. And this article really resonated with me and kind of pulled a lot of this stuff together. And it talks about this whole, hey, software is becoming such a big part of our society, and yet we continue to have problems. And the fear is that there's going to be some big catastrophe. And that, and you might argue this article might be a little hyperbolic, but there were some interesting things in it. One, it was talking about a day where there was a variety of different software failures. A 911 system in Seattle went down, and they had halt trading on a New York trade system because of a software problem, and an air traffic control system went down. And people were legitimately thinking that this might have been a coordinated cyber attack. But later on in the day, as things unfold, they realized, no, it's just a coincidence. It was just another day in the world of software systems. And so it is a great time to be a developer. The systems we're building are more and more complex and more integrated in our lives. The opportunities for us are really incredible. The ability to impact people's lives. But we as an industry seem ill-prepared to be ready to meet that challenge. And I've been, like Scott had mentioned, I've spent quite a few years in this industry, and I've wrestled with this. So a lot of times they talk about people's experience in software as spilling blood on the floor. Well, I can assure you, I've spilled plenty of blood on the floor over the years, and a lot of it was self-inflicted. Today, what I hope to do is share with you some of that experience and some of the things that we have identified that have really made a difference in our ability to kind of meet some of these challenges. And so I have 4 goals here with this meeting. One is I'd like to maybe challenge the status quo of what the norm is for a software development culture. Maybe get you thinking a little bit about our individual roles and responsibilities within these cultures and within our companies. 3, maybe share some insights with you and some interesting facts and figures that might help you when you're talking with people about the things we need to do to change. And 4, hopefully, maybe inspire some of you to be change agents within your own organization. Now, as Scott had mentioned, I have a bit of a diverse background. And I don't come from a classically trained computer scientist or software engineer. I actually have a degree in electrical engineering. And I think it's important. I'm going to weave through some of my own personal journey in this talk because I think it's important. Because some of the opportunities I've had have given me kind of an interesting perspective and put me in situations that really were very impactful in terms of my own personal growth and trying to wrestle with this challenge that we have. So I graduated from UNL in 1988. I will tell you that I do have some college credit in software development. I have 3 credit hours of Fortran programming. That is the extent of my formal education. And I went to work at a company in St. Louis called McDonnell Douglas. And there I was hired to be a systems engineer, which I didn't even know what that was when I went to work there. But what I was responsible for was making sure that as we integrate avionics and sensor systems on these military aircraft programs that I worked on, I was responsible for making sure that those integrations were successful. Cradle to grave. I worked with the customers to identify the requirements. I articulated design criteria back to them and how we were going to accomplish this. I worked with the hardware engineers and the software engineers. I did a lot of the testing. I worked with the customers, they were testing it, all the way to these things going out in the field. That was my responsibility. And I realize now how really valuable that experience was for me. It was fun to work there, but it really created a foundation for me that has really been critical to kind of where we're at today and the things we're doing today. My wife is from Valentine, and so I'd finished my graduate work, and we decided we wanted to move back to Nebraska and maybe raise a family and be closer to our family. So in 1995, we came back, and I pretty quickly got a job at a small commercial software company that built practice management software for small medical, dental, and chiropractic companies. And I kind of came in as a quasi-project manager. Really what they brought me in for was to try to create some structure around what was going on. Because they were in the process of replacing their Mac-based system with a new Windows and Mac-based client-server system on a relational database. But it was challenged. That project was challenged. And really, it was a stark comparison from where I'd come from. Really, it was almost the tale of two worlds. You know, on the one hand, is systems engineering that I was doing at McDonnell Douglas. On the other hand was my introduction to commercial software. In that process at McDonnell Douglas, things were very structured, all right? They put things in place that were industry best practices for how to ensure that we're managing these complex processes. In this new company, when I came in, there really was no formal process that I could tell. There was not even a collective understanding of the requirements. They actually isolated part of the team that was building the new system and didn't allow them to talk to all the people who had worked on the old system. So there was no way for them to even exchange domain information. The success rate for the projects that we dealt with at McDonnell Douglas was very high. You know, granted, some of them go over budget and things like that. But when they got to the field, they worked. In this particular instance, like I said, very little coordination with key stakeholders, and the project was way behind schedule. And actually, even though some of them actually got to the field, the project really never took off, and the company was required to go in another direction. So any of you guys that have been, guys and gals that might have been doing development in the 90s, that experience probably would sound familiar with you. And a lot of projects were challenged in the 90s. You know, the vast majority of them were unsuccessful. You know, very few projects were on time and on budget. And you might assume that in the 25 years since then, we've probably made significant progress on that. And you would be wrong. Although we have had some additional successes, we continue to have significant challenges within our projects. What's more is our productivity levels. You know, what we're able to produce is relatively flat and has been for years. As a matter of fact, there's a lot of data that shows that there's just as many companies that are getting worse as those that are getting better. And the CMMI Institute, which developed a whole protocol for kind of evaluating maturity of organizations, also collected a lot of data on that. By and large, there is no standard processes being followed across industry. A significant number of companies don't have any real processes in place. And this is today, 25 years later. We often spend half of our time doing nothing but fixing bugs, right? I'm sure that probably resonates with people. And what are the primary sources of this rework? Well, oftentimes we're just too quick to jump in there and start writing code and not really think through the requirements. This one here is really a personal passion for me. A lot of times the software architectures we build do not age well. They rot, they become rigid and fragile. They don't really anticipate the inevitable change that is going to happen within our systems. And even though a lot of companies are implementing Agile, they still struggle with a lot of the quality processes that need to come along with that, or any process or methodology you're using. People don't really know how to test, and we're not using, I think everyone agreed that continuous integration and continuous testing is something that we should be doing on all our projects, but very few of them are actually doing it. And while the general public is probably a little bit skeptical and chuckles at the software problems and our inability to kind of have a real strong track record, what's probably more important is that the leaders in our business are beginning or are losing confidence in us as a result of these chronic problems. It was late, it was over budget, it was poor quality, it didn't meet the user's needs. I can understand their frustration. So if, kind of getting with our hero-villain theme with this, if our experience in software product development were a superhero movie, who would the villain in that be? Now, no way am I saying that what we're doing is evil, so don't get me wrong on that. But again, if these stories had protagonists and antagonists, my feeling is we would often be more on the antagonist side than on the protagonist side. And yet we're capable of some unbelievable things. Kathleen mentioned the Mars rover. If anybody has ever watched the 7 Minutes of Terror about the landing of Curiosity, which is essentially a car, it's a 1,500-pound rover that was landed on Mars completely autonomously. I would Google that and watch that. The understanding of what it took to actually build that system and land that rover, I think it's one of the high points of engineering that we've ever had. It's truly amazing. And every time I see a SpaceX booster, first stage booster self-land back at the landing site, it gives me chills because I know what it takes to do that. But there's been plenty of successes in what we're doing. So we know as a field of computer science and software engineering how to do this, but we're not doing it consistently. So yeah, it's never been a better time to be a software developer. But what really concerns me is this tsunami, if you will, of complex software problems that we're going to want to try and solve that are continuing to come down the pipe. 20 years ago, we built an e-commerce platform in the late 90s. So it's been 20 years since I built that platform. And I look at I think back at the initial things we built there, I'm like, wow, those are really naive. To build an e-commerce platform now, it'd have to be an order of magnitude more complex to even be viable within this industry. So things are not going to, the problems we're solving are not going to get simpler. And this doesn't scare me that much, but I could see this happening. If, God forbid, some catastrophe happens, people are going to want some accountability. People are going to want some regulation. Somebody's going to take control of this and try to enforce something on us. And I would rather we take control of that now before we ever get to that. And even if regulation wouldn't come, the survival of our businesses probably depend on our ability to really step up our game. This stat blows me away, that last line there. This guy predicts that 75% of the S&P's 500, the current S&P 500 firms will be replaced by new ones by 2027. And that's a total indication of the agility that these successful companies have, the ability to get to market and react to market changes and things like that. And that's what we enable. We enable that or disable that by the decisions we make in terms of how we build systems. So I think it's important to think about how we got here. Okay, how do we get to this point? Because I have some thoughts on this, and the good news, I don't think this is entirely our fault. So I'm going to give you a bit of an analogy here. So think about a physicist and a civil engineer. They both share a common body of knowledge, the field of physics. An undergraduate physics major and an undergraduate civil engineering major take a lot of the same physics courses in the same classes. But the physics major goes on to get a physics degree, and the civil engineer goes on to get a civil engineering degree. I don't think we're ever going to ask a physicist to design a bridge. They're probably not going to be ready to do that. They probably wouldn't even know where to start. Because that is the difference between a scientist and an engineer. Fred Brooks put this, I think, brilliantly. A scientist builds in order to learn. They're not as concerned about whether this is a viable artifact. This isn't going to be used by the consumer. Their whole goal is to try to better understand the nature of physics. And an engineer learns in order to build. They want to have enough of this body of knowledge to be able to effectively apply it to some sort of a public or commercial means. And if you think about our computer science education that we have these days, and I think to get into this field and really work on complex systems, you have to have a formal education. Most computer science programs have one class that says software engineering. So they have a 3-credit-hour class, and it's probably a broad overview of this entire field of software engineering, and probably very little application of it. What we need is a civil engineer would have 2 years of civil engineering training in a variety of different classes regarding design and whatnot. And so we weren't really preparing the kids coming out of college to really kind of jump in and know how to manage this complexity. Yeah, they know a lot of information about computer science, but they're not really prepared to bring that all together. And the end result is we have developed kind of these rather large pockets of poor software engineering literacy. And there was an interesting study I came across the other year. Their premise of the study was they wanted to understand when and where and how code smells and design smells got into software. What they found out was, because they were thinking it was somehow related to how software was being maintained, what they found was statistically most of those code smells and design smells were in there day one. They were part of the original design. So Agile's been a big deal over the last 20 years, and I'm a huge Agile and lean processes fan. And we've been using these methods and continue to use these methods ever since probably the early 2000s. And we're just like everybody else. We probably hybridize it to fit our own development culture. But Agile is not a silver bullet for these problems we're facing. Because one of the epiphanies I had was that there are two forms of complexity within software. One is the requirements complexity. And that is really where Agile is targeted at. How do we better manage the volatility of requirements? And how do we tighten the feedback loop with customers and stakeholders? And I think Agile is brilliant with that. But I think it's very limited in its ability to solve this other type of complexity, which I would call solution complexity. So in a lot of cases, a lot of teams are successful and create agility just through brute force. They have some talented engineer or group of engineers that have some sort of tacit knowledge that they're not even realizing they're tapping into that somehow manages to make their project successful. And it's been shown that a lot of these teams have blind spots with that. They don't often realize that they do or do not have some of this knowledge. But planning has been shown to compensate for that. The problem is, I would refer you back to the CMMI stats. By and large, we're not doing any sort of planning before we start coding. And it's really been amazing, the development of tools that have happened over the last 10 or 15 years. I can remember when we first tried to use NUnit back in early 2000s, and now these unit test tools are so heavily integrated in our development environments, and the frameworks that are out there, it makes it easy for us to create responsive web applications and things like that. Well, those are not going to solve our problem as well. One is they tend to be very temporal, right? And I think it's, relying on frameworks or some sort of a tool set to improve the quality of and outcomes of our systems is a little bit like saying, if I just had a better paintbrush, I'd be a master artist. It's not how you use the tool. It's not the tool that's really, it's how you use it. And it's much better for us to really focus on those core principles that transcend the frameworks, because there are some principles that transcend those frameworks. And lastly, I've been thinking a lot about head coaches over the last few years, as I suspect a lot of Nebraskans have. And I've come to appreciate that certainly in college football, the quality of your head coach makes a huge difference. And I think the same is true within software development teams. It is a team sport. And I think a lot of teams are missing some of those people that really are a head coach. They end up just being their co-developer who may be more senior. And I'm not sure there's enough focus being put on that role of leadership. So getting back to my own personal journey. So I had all these issues, this chaotic environment, and over time I went to some other companies, and I even worked at a startup that I helped co-found in the early 2000s. And all along the way, I was continuing to have problems with this. And in my mind, I'm trying to reconcile, why is this so much different than my experience at McDonnell Douglas? Why is there so much chaos? I thought we were doing things right. I can remember spending days working with some folks to design this really nice object graph of a portion of this e-commerce system, and it was great, and it worked great for about a year. And then as new requirements came in and new features came in, all of a sudden it became easier to do things to circumvent this overall design than to work within the design. I'm like, this can't be the way that we're doing these things. And I'm certain you've probably heard this, but I couldn't help thinking, is this the nature of software? Is this just, an unsolvable problem? I really didn't believe that, but that thought creeps into your head, and you often hear people talk about that. And then in 2010, I went to Tech Ed. Remember Tech Ed? I used to love going to Tech Ed because they would always have program managers that would give talks, and then they would be out in booths and you could go up and talk to them. You could talk to the program managers from the Visual Studio team. It was awesome. I loved that, you could interact with these folks and give them your ideas. Well, at this particular one in 2010, I went to see a session called The Zen of Architecture. I mean, it was a really interesting title, and I was like, this, again, I'm thinking this is kind of in my area of interest, The Zen of Architecture. And that was a profound moment for me, because then over the next 6 months, I interacted with the guy who gave that talk, and I really had 3 epiphanies that came out of that. One is it cemented in my mind my experience as a systems engineer in my experience trying to manage the software development process. It really kind of connected some vague dots in terms of how to approach both of those. Maybe more importantly, it opened my eyes to a body of knowledge within computer science that has been developed over the last 50 years that I was totally unaware of. There's been a lot of work out there in terms of trying to understand the nature of complex systems and why they struggle and what we can do and the decisions we can do and the processes we can follow to help manage that. But it was completely unknown to me. And then finally, it made me start thinking about software as just another type of system as opposed to this separate thing, which allowed me to have confidence in kind of leaning on some of my experience that I had at McDonnell Douglas and try to fold that into the things we were trying to do. So today, since that time, we've been on this kind of continual refinement and maturing of our processes and understanding. And I have benefited from the fact that I've worked at a lot of startups and I've helped build software for a lot of startups. And so that created kind of an interesting laboratory where we could kind of continue to try these things very rapidly over a period of time and really refine some of the stuff and convince ourselves that this stuff really did work. It wasn't just academia. And the results have been profound. And so we've continued to kind of deepen this understanding, and I talked about this duality of complexity between requirements and solution complexity. And I identified these hallmarks of sound design, which I know all of you probably are familiar with, this notion of coupling and cohesion. But those 2 things are so critical to be first and foremost in the design decisions we're making. They really are going to dictate whether we're going to build systems that are maintainable and that provide agility, or whether they're going to decay and rot and be unmanageable. This is a key one for us, and this is the thing I learned in that first 6 months. The importance of decomposing and designing systems that enable change as opposed to resisting change. And that whole concept of what Yuval Louis from iDesign calls volatility-based decomposition is such a profoundly different way to look at the way we decompose systems that I would strongly encourage you to look that up. And I should also mention, like Kathleen, I will make all these slides available afterwards on the site for you. They're also meant to be a reference. And this next one's leaning back to kind of my experience at McDonnell Douglas, this need to do critical thought processes prior to what I call the manufacturing part of software, which is the fingers on keyboard. Too often we're just jumping straight into code. And then really deeply understanding the nature and quality of defect detection in software, which is a lot more complicated than just throwing some code over the wall to QA. And then this need for strong leadership. And so where we like to sit today, where we like to think about where we want to be, is at this intersection of lean development practices and structured software engineering discipline, to live within there and to integrate these processes so we get the benefit of this rapid ability to react to new changes through our interactions with product owners and stakeholders, and we're building a software system along the way that is easy to move and migrate and maintain and extend. That's where we want to be. We want to be in that space. So we built 3 particular companies that I'd highlight here that were primary test beds for a lot of these technologies and processes. EliteForm and Beehive were both launched in 2011, built by fairly small teams, teams of less than 10. Beehive is a as a infrastructure management platform for small to medium-sized cities. It's hosted in Amazon. It's in use by about 80-some cities, including Lincoln, Nebraska, and it manages all of their public works infrastructure. Think wastewater, water, electrical, streets, roads. EliteForm is a computer vision application for high-performing athletic programs. And what it does is it has a 3D depth camera that sits at these power racks, and it tracks the velocity and repetition of athletes as they're lifting. Built on, we had the inspiration for that was when the Kinect camera came out with the Xbox. But it's all our own algorithms. We basically just take the raw data off the camera and developed algorithms to do that. And then Ocuvera is another computer vision application that watches patients in a hospital bed and predicts when they're going to get out of bed unattended to help prevent falls. So these 3 products, even though 2 of them are computer vision, they're completely different algorithms and whatnot. 3 products that are in 3 very different industries. If you looked at the code base of those products, and if you looked at the processes we followed, and if you looked at the culture of the teams that were developing them, they would be almost indistinguishable. Even the code base, the way it's organized, the way things look like they were designed and ran by one mind. And that is a hugely powerful thing to have within a system. It makes it that much easier to move people around, for one. It makes it easier for people to get in there and maintain the code. So I've talked a lot about this very abstractly, and I thought it'd be beneficial to kind of give you some examples of where a lot of us are and where I think we need to be. And I'll continue this with this villain-hero theme we got going here. So when it comes to planning, I think a lot of people intend to do planning. They wish they could do more planning, but when push comes to shove, they end up abandoning that. You know, there's too much schedule pressure or whatnot. So I'd like to do it, but we just couldn't get to it, or we couldn't afford the time. The hero, though, knows that the decision to not do planning has long-term consequences for their product and their platform. They understand the value of that. When it comes to estimation, how many times have you heard an estimate from somebody that said, oh, this will probably take 2 months? And it might, in fact, take 2 months. I think it's more likely to take somewhere between 2 months and 6 months. And why is that? It's because they don't really understand what they need to do to build that. And like any problem solving, you don't want to just tackle the big problem. You want to take a big problem and you want to break it down into smaller problems that are easier to tackle. Estimation is the same way. You can use estimation to break down these complex, abstract features that you got from a product owner, continue to decompose them into smaller and smaller requirements. Maybe set a metric that says, I'm not going to allow an estimate for anything that's more than a week. I can assure you, if you put this in place, you'll be shocked at how much more information you understand about the feature you're about to develop than you would have on day one. We all deal with hidden assumptions, and we just don't know it. The only way to reveal a lot of those hidden assumptions is to articulate our thought processes in some form. So analysis, and what I'm talking about here is I'm talking about what is the developer doing beforehand. Well, I've done this and I've heard this. Let's just start coding and we'll figure things out along the way. Well, the hero knows that, hey, you know what? I got some uncertainty here. This seems like it might be a little tricky, and there may be some things I'm not considering. So I'm gonna take some time, maybe an hour or two, and I'm gonna really think this thing through. I'm gonna think about failure modes. I'm gonna think about how I'm gonna test this. I'm gonna think about maybe some security issues. And I'm gonna write those things down, and I'm gonna share them with my team lead, and I'm gonna share them with the product owner and get their feedback before I actually start jumping in there and doing some code. And when it comes to design, again, I think a lot of people would love to do design. They'd love to do architectural planning. I think a lot of people don't really know how to start it or don't have a defined set of kind of design criteria. What are the rules I use to decompose systems? And then there's a whole other set of people that say, you know what, let's not concern ourselves with that. We don't even know if this is going to be a viable product. So we're just going to build an MVP. We're going to slam this thing together. And once it gets out there and gets some traction, we'll come back and fix the architecture later. I can assure you the only chance you're going to get a chance to go back and fix it later is if your product doesn't have customers. Because as soon as your product starts getting customers, what they're going to be telling you they need is, oh, this is great, I need this feature, I need that feature. And the amount of pressure you're going to get from product managers and everybody else to extend that product at that time, you will have no room for this, right? So the hero says, look, I wouldn't build a house without a plan. This software system is at least as complex as my house, so why wouldn't I have a plan to start this? Quality. I talked about this. Hey, this works good on my desktop. I'm just going to throw this over to QA. The hero says, actually, the only way we're going to meet our quality metrics, and I believe our quality metrics we should be shooting for here. I'm assuming nobody's writing flight control systems or heart-lung machine software or anything like that, or we're not writing software to land rovers on Mars, right? We're building enterprise applications or maybe commercial products. Well, our metric for defect detection should be we find 90% of defects before they get to the customer. So they're only finding 1 in 10. And that might seem like, well, they're going to find 10% of the bugs. Most companies are nowhere near that sort of a track record. The only way you're going to get to that, there is no one quality thing you can do statistically that will get you there. Most of these quality initiatives I've listed here get you about, at best, 50 to 60% defect detection. You have to layer this in. You have to have a strategy. Quality has to be something that every aspect of your product development lifecycle has to have some aspect of that as part of it. And leadership. I talked about leadership before. A lot of development teams, they put their best developer in a leadership position. And I think intuitively that makes sense, right? There's something that makes them the best developer, right? And so they can probably share that with the employees. Well, the hero organization says we need more than just that. We recognize that we will only be the best when we have development leads that are good coaches. And they can coach people on these design principles and standards and keep people on the rails. Because entropy within the software and entropy within processes is a real thing. And it takes constant nurturing to keep everybody on the same page. They ensure conceptual integrity of the design. They don't let the design decay, right? Because they built this system to enable change, and they are the ones who are going to protect that against poor decisions. They maintain a big picture. That's super valuable. A lot of developers I kind of know my thing, but I don't often know the big picture. Somebody has to be that chief engineer that understands the big picture. And they're proactive about communicating both within the team and outside the team. And they personally have accountability for performance and quality. And in our team, we use a pull request model. I assume most people are aware of that. It allows for a code review before being merged into the main branch. And in our team, there's only one person who merges code into the main branch, and that's that lead developer. So they see every bit of code. And what they're looking for is, they're obviously concerned that it satisfies the feature. They're mostly concerned is this code that I want to merge into master and be part of our main program here. And then finally, philosophically, I know there's still people out there who just feels like, that's just the nature of software. I don't know why we're beating our heads against the wall. There's nothing we can do. But the hero says we must change. We have to get control of this. Our businesses depend on our ability to get control of this. So we really do need to transform our development team cultures. And I suspect a lot of you out there are seeing some of these things I mentioned up there and saying, yeah, we're doing some of that stuff. And that's great, but we can do more. We need to improve and grow our software engineering literacy as an industry. We need to implement structured, disciplined processes for how we're building software. And I can assure you, you do that, the quality of your software is going to get better. Lots of evidence for that, both statistically in research, as well as I can tell you from personal experience with people who have companies that are doing this. And successful companies get this. They understand this. They measure software productivity and quality accurately. They use that information. They plan and estimate software projects accurately. They have capable management and technical staffs. They have consistent processes and execution across all their teams. They have good organizational structures. They have the appropriate level of involvement from stakeholders. And they have effective software methods and tools. They have a formal and consistent design methodology. They have adequate environments. Communication among staff is very important. And they're able to reuse substantial volumes of their software deliverables. And by I'm just not talking about code, I'm talking about design patterns and things like that. They share that across those teams. So this is not an easy process, I can tell you, but it is, I believe it is essential. And I wish I could tell you could cherry pick some of these things and get to the end game where you want to be, but I don't believe that's the case. I think it requires attention across the spectrum of the things I've been talking about here. It is really, in my opinion, the sum of these parts that gives us the success. And along the way, I've identified a handful of these principles and patterns and thought leaders that have been hugely impactful and influential in the transformation of our own team. And I wanted to share some of that stuff with you here. I would point out a couple of things on here that you probably might not have even heard of. This concept of information hiding, which was developed in the 70s by a guy named David Parnas. And he was concerned with how we build and maintain complex software systems. And now on the right, the thought leaders there. These are folks that I feel like have devoted a substantial amount of their lives to dealing with managing software complexity. And some of these guys were more in the 70s, and some of these guys are contemporaries of us right now. And if somebody would ask me a handful of books that I would recommend they read, this would be them. Steve McConnell's Code Complete. What a great book that brings together an enormous amount of information into a single volume. If I had to have one book on my shelf, it would be that book. The second one is a book by Fred Brooks, who famously wrote The Mythical Man Month. But he also wrote a book, it's a published book of his essays on design and design of systems, and they're really fascinating. And then Robert Martin, who one of the original signature guys on the Agile Manifesto, recently came out with a book called Clean Architecture, which I think is a really interesting introduction of how cohesion and coupling need to be an essential design criteria within the way we're building systems. Capers-Jones Applied Software Measurements. That book is this thick, and it's full of stats about how we develop software across different industries and different team sizes. Really an interesting book. And this Engineering in the Mind's Eye is not a book about software. It's a book about kind of the nature and the art and science of engineering. And it's not a long read, but I just thought it's one of the most interesting books I've ever read. And then this last book, I throw this one up here because I think this is kind of cool. That book was written in the 70s called Structured Design. I'm sure that book is familiar with some of the folks out there like me that have gray hair. But there were things that were brought forth in that book that are just as meaningful today as they were then. And that's why I'm talking about these principles that transcend the latest technology and the latest framework. These are core things that the more we understand them, the more we embed those into the decisions we're making, the better we will be. So we are the key to the success of these projects and the agility of our businesses. And the good news is there's a lot of resources out there. Now, I realize that you go to Amazon, look up software books, you get all kinds of stuff. But that's why I wanted to put some of those resources on there to kind of steer you in a particular direction for a few things that I think will really be beneficial to you. The bad news is, though, it's going to be hard work. It's going to take dedication and devotion, as well as maybe a significant amount of evangelism to get people to buy in. My personal experience is people are hungry for a path to where they can have more fun writing software than not, to spend less time dealing with the headaches of software development and software maintenance, and more the fun things that brought them into software in the first place. So this is my hope, is that maybe somehow I've inspired you to be an agent of change within your organizations, to be the hero. So work to develop a complete set of knowledge and skills to handle both requirements and solution complexity. You know, this whole idea of increasing our software engineering literacy. Study this, read this, think about it, talk to people in your group, talk to people in other companies, debate this stuff. This is the sort of stuff that we've been really doing. I've been doing it for about 25 years, but really intensely over the last 10 years. Work to establish a disciplined development culture. Define some processes. Let's not do things ad hoc. Follow the hero way, the examples I gave you there. develop some personal best practices and some team best practices, and then enforce them and refine them and learn from them. Start thinking about the leadership positions in your organization and start broadening the responsibility of that person and make that person somebody who could really be a coach within your team and not just the best developer. And then let's not forget the product owners and stakeholders that are not in development and the need to coach them and help them understand the importance of the processes you're following, the value they provide, and why they should care that they're supporting us in terms of what we're doing. So I'm here. I was here all day today, but I'll be here tomorrow. I'd love to hear your thoughts, get your feedback. Here's my contact information. Feel free to reach out to me. Any questions or thoughts? I love learning what people are doing. I'm not the board, but I do like to kind of assimilate people's best practices and the things they've done. I think it's important for us to share this knowledge in a way that allows us all to grow. So thank you. I appreciate your attention. Have fun at the party and have a great day tomorrow. Thank you.